Hello students, welcome to the session. See, in the distributed systems, we are going to the last algorithm in the synchronization, that is the elections algorithm. See, coming to the election algorithm, why it is so important in synchronization concept in the distributed systems is in the algorithms which we have just discussed about the mutual exclusions. So there we are going to select one coordinator over there, and depending on the coordinator process, all the remaining processes are dependent on this, right? So if any process want to utilize a shared resource, that process will be asking for the acceptance that I want to utilize this resource as a request. Now coordinator, after seeing that if the resource is idle, it will give the OK message. If the resource is not idle, it will be saying that it will be not giving any response. It will be just waiting until this resource becomes free. If it becomes free, immediately this will be giving the OK message to the process which has requested for the shared resource. So that is what is happening under the guidance of the coordinator, right? Now, election algorithm is very important when we are selecting a coordinator first of all. So how to select the coordinator? If the existing coordinator fails or crashed out someplace, or if something happened, the coordinator gets recovered from so and so attack. So all this will be taking place, right? So all the negative shades if you are having. So at that moment, how to go with the coordinator selection will be the session of the today. So for that we will be having two main algorithms. The one is the Boolean algorithm and the second one is the ring algorithm. So thus the election algorithms are playing important role, and we will be discussing the two algorithms within 1 minute now. Now see here, whatever we have just discussed, how is a new coordinator chosen? If the existing coordinator fails, then how the actions of the processes which are dependent on the coordinator will be there. So that is what the election algorithm importance. Now let us see the first algorithm, that is a Boolean algorithm. See, coming to the Boolean algorithm, this is very simpler, that all the processes in the distributed environment will be getting a selection message that our existing coordinator is no longer, and whoever want to be as a coordinator can give their acceptance. So that is what will be happening. Now in the first step, if the coordinator gets crashed or failed, immediately all the processes will be under waiting mode, right? So all the processes, instead of starvation, they will be realizing that something has happened to the coordinator and we have to do something immediately. So all the remaining processes which are there in the network will be giving election message to each and every process, right? So after giving the election message, like this should be initiated by one process, any one of the process. So initiation is very important. Analyzing that coordinator has been failed or are in the recovery process. So that is very important. So there will be an initiator process. That initiator process will be given the election message until and unless this existing coordinator gets recovered or something importance will be taking place, right? Now at that moment, the initiator will be sending an election message to all the processes. Now after giving the all processes with the election message, all the processes which has interest, they will be giving the OK message back, right? If they are not having any interest, no response will be given. If no response means, that indicates that they are not able to get into this coordinator. Now after getting the OK message, then immediately we will be getting the highest number of OKs, so that we will be taking the answer as this process will be winning this election. Now after winning the election, from that time that process will be called as a coordinator. Now meanwhile, if the failed coordinator recovers, so even that also will be getting the election, right? So meanwhile the other coordinator started, so the other coordinator will be the finalized coordinator, right? So this is a procedure which we have just discussed from that. So receiver sends an OK message if they are interested back to the sender request as an election message, right? So then all the processes gives up apart with the OK message. So when the new coordinator announced, the existing coordinator must be stopped as a coordinator. So that is what the Boolean algorithm is. So Bully algorithm is nothing but the algorithm, the process which is having the biggest number in the OK acceptance will be given chance to be as a coordinator. See here, as 7 is the existing coordinator, it was crashed due to some reason. Now all the remaining processes which are there from 0 to 6 will be able to realize that something has happened to the coordinator 7. So immediately all the remaining processes will be getting a alert. So after getting alert also, remaining processes are just waiting, but 4 took the initiation, right? So this initiator part is very, very important in the Bully algorithm. Now 4 took that initiation and gave election message to even to the crashed system also, because if it is alive, immediately it will be giving OK message. With that OK message, everyone will be stopping for some time. So as this is crashed out, it will not give any response, right? So whoever gets the election message, those if they are interested, then they will be giving the OK concept. Now after giving the OK message, now 5 as a next initiator, it will be giving election message to all its the processes which are running in that application, so that everything will be getting the election message. Among this, 6 gave OK message. Right, see, 6 is giving the OK message. Now, among all those, 6 gave one here and here. See, OK message here. So, 6 is having the highest number. Right, see, highest number. Now, among all the things, 6 will be selected as a coordinator. From now, 7 is not a coordinator, which see here, the blue thing which we have given till here, after 6 has selected the coordinator, we are not representing that as a coordinator at all. So from now, every process in the application will be utilizing 6 as a coordinator. If they want any resource to be utilized, they will be asking 6 by giving a request that I want so and so R1 resource. So if the resource is empty, 6 will be giving OK message that you can utilize it. If R1 is busy, 6 will not respond anything, it will be waiting for some time. So this is a process of Bully algorithm under election, right? So this is a part of Bully algorithm. Now coming to the ring algorithm, it is very simpler one. See, every process in the network will be arranged in one ring format. So we know ring topology, right? So in the ring format, we will be arranging all the processes. Now, as similar to the previous algorithm explanation, 7 is a crashed out coordinator. See, coordinator is no longer available. Something has happened to that process. It has been killed or something happened. So the coordinator has been failed. Now, all the remaining processes which are there must be, the initiator here also important in this also. So 4 is the initiator. So 4 will be giving its process ID and it will be sending to its immediate adjacent process. So 4, it will be adding its own process ID and it will be sending to the immediate process. Now process which receives that ID will be assuming that, so this is the election procedure. So 5 will be taking 4 and 5 and it will be giving to the adjacent. If the adjacent is not working, so after excluding this, we will go to the next immediate right thing, right? So 4, 5 and 6 will be assuming that this is the election procedure. So it will add 4, 5, 6 and it will be sending to the 7. But 7 is not alive, it has been crashed out. So its next process will be getting the chance 4, 5, 6 and it will add its own process ID. So like this, every process will be including their own process ID until and unless it reaches the initiator back. We will be repeating this process. Now 1, 2 and 3 also will be added, right? So among all these, ring will decide one process which is having the maximum process ID, right? So that is what the statements which we are giving over there. See here, the maximum which is having the maximum ID number will be winning the election. So in this 6 will be winning the chance to be as a coordinator from that time, because out of all the numbers 4, 5, 6, 0, 1, 2, 3, out of all the numbers, the maximum process ID which we are having is the 6. So the 6 will be selected as a coordinator, and all the remaining processes will be a normal processes. From that time, even after 7 recovers also, 7 will be as a normal process only, because we will be giving all the requests for the shared resource will be given to the 6. Right. So as we have given this election procedure, after it recovers, it will receive that 4, 5, 6, 7. Right. So like this, and 7 will be assuming that among all the numbers, out of me 7, 6 is the largest number. So 6 might be the coordinator. So even 7 will be starting giving its request to the 6. Right. So this is a coordinator election procedure which happens in the centralized and distributed environments. So if you have any doubts in the synchronization algorithms throughout, we have discussed 4 main types of algorithms, and every algorithm we have discussed internal algorithms also. So just go through all the 4 types of algorithms in detail. If you have any doubts, please be free to contact anytime in the college or through comments. Thank you.